Problem E says the owner also decides that if the hamburger patties are too small, customers may notice and get angry. She decides that hamburger patties weighing in the bottom 10% may be noticeably small and should be remade. What is the cutoff for the bottom 10% of weights? This question is different from the ones we've done. Previously, we've been given an X value, and this time we don't have an X value. Instead, we have a percentage. We can still draw a picture based on this, though. Now, the mean of 6 represents a percentage of exactly 0.50. We are interested in the bottom 10%. Now, for the bottom 10%, we look on the left side because that's where the lower numbers are. We'll draw a mark to represent 10%. But we don't know what value goes with that 10%. Previously, we were given an X value and asked to find probability. And to do this, we used Norm.dist. In this case, we don't know the X value, but we do know the probability. Now, Excel has another function that does the opposite, that changes probability into X value, and this is called Norm.inverse or Norm.inv. To use this formula, we'll say equals Norm.inv. Place your probability first, comma, your mean, comma, your standard deviation. This will return an X value as the answer. So let's make our list. We'll need a probability, specifically probability of being less. Then a mean and a standard deviation, and based on that, we can get an X value. Now our probability of being less is going to be 10%. Once again, remember that we wanted the bottom 10%, so that means go left from 10%. So that 0.10 or 10% represents this red area I've shaded. We'll say 0.10 there, a mean of 6, and a standard deviation of 0.4. Now to get the X value, we'll say norm inverse. Click the probability first, then the mean, and then the standard deviation. When we press enter, the bottom 10% cutoff is 5.487. This will be our answer for part E. Problem D says, the owner of the restaurant does not want to accidentally use too much beef in the hamburgers because they may run out. She decides all hamburger patties weighing in the top 5% should be remade. What is the cutoff for the top 5% of weights? Once again, we can draw a picture. We'll mark the mean at 6 and 0.50. The probability at the mean is 0.50, and the value is 6. So we'll mark probabilities with 0.50 and values with X. Now, we want the top 5% to be remade. When we mention the top, we're going to look to the right side. So we'll have a small part of the graph, 5% of it, or 0.05, on this right side of the graph. We can refer to this as P greater. So we want the probability of being higher than this green mark on the graph to be 0.05. Now, the thing is, in Excel, we can't actually use P greater. Excel will always use P less in its formulas. So therefore, we need to take one additional step at the beginning of this problem to find p less. Now to get p less, we always take 1 minus p greater. So the area we're actually interested in here is this area I'm marking in purple. This area will be 1 minus 0.05, which is 0.95. Now, if you don't want to do that math by hand, we can always start by entering p greater into Excel. Not every problem will have a p greater, but if they mention a top percentage, that is going to be p greater. Our p greater is 0.05, and then we can find p less, the probability that we are actually allowed to use in Excel, by saying equals 1 subtract the p greater. When we press enter, our p less is 0.95 indeed. Now remember, for norm inverse, the other things we need to collect are these. We'll need p less in particular, comma, the mean, comma, the standard deviation. Now, we have p less, but let's also get the mean and the standard deviation. Based on that, we'll get an x value. Our mean is still 6. Our standard deviation is still 0.4. And then to get the x value, we use norm inverse. So, say equals norm inverse. Click the p less, not the p greater, because Excel doesn't understand p greater. Comma, the mean, comma, the standard deviation, and close the parentheses. When we press enter, we get that the value that corresponds to this probability is 6.658. That will be our final answer for problem D.